So, good morning. In today's session, we have to study about DC to DC conversion. So, here, these are the objectives we have to learn here. Firstly, we will see about introduction to DC converter. Because we are using the voltage regulator and we are giving the input that will be also a DC, but we are supposed to get the output that will have fixed value. It will not change. That's why we are using the voltage regulator to get the fixed amount of voltage at the output. And if you see, there are different types of voltage regulator like linear voltage regulator and the switching voltage regulator. So switching voltage regulator, we can call it is as a switch mode power supply in which we are using the PWM. So here we are supposed to study about types of voltage regulator. These are nothing but linear voltage regulator in which we are supposed to see for series voltage regulator and the shunt voltage regulator. And other type is switching mode power supply, or we can say it is working as a switching voltage regulator, switch mode voltage regulator. And we are supposed to see about advantages and disadvantages of linear and switching mode power supply. So here what we are saying, we are converting the DC power into DC power, but where we will get the value of DC power that will be constant. So here we can say DC to DC converter will convert DC power to another DC power level to that will be voltage or current. It means what? Here we are converting DC voltage to DC voltage or DC current to another DC current. So if you see batteries we are using, that's these batteries will show systematic diagram as the source of DC voltage. But usually if you see, we are saying DC voltage source is nothing but it is a power supply. So DC to DC converter are important portable electronic devices which we can use whenever we want to change the DC power, that will be voltage or that will be current, efficiently from one voltage level to other voltage level. It means what? Here we can increase the value of DC voltage or we can decrease the value of DC voltage or current. It means DC power. So we can say a power converter will generate the output voltage and current for the load from given input source, and that value will be increasing or in decreasing amount with respect to the input DC voltage or current. So depending on the specifications of the applications, we are having different types of the power supply. These are nothing but switch mode power supply, or we can say switching voltage regulator, and either it will be a linear regulator. It means what? It can be a series DC to DC converter or shunt DC to DC converter. So if you see, there are lots of applications for DC to DC converter, like a car battery 12 volt must be stepped down. It means what? We can decrease the value from 12 volt to 3 to 5 volt voltage to run DVD, CD player in our car. If we see, we are using the laptop, computer, cellular phone. So here, if we are using these devices, we can say here battery voltage must be stepped down to run several sub-circuits, each with its own voltage level requirement from different supplied by the battery. It means what? As per our requirement, we can step down the voltage from the given supplied voltage. जैसे हम कार के लिए we are using the 12 volt, but when we are supposed to play the DVD, at that time we will require less amount of voltage, so we can step down that voltage by using the DC to DC converter. If you see 12 volt DC must be stepped up, we can increase also to plus minus 40 volt to run a car hi-fi amplifier circuitry. It means what? We can increase that voltage or we can decrease that voltage. So these are some typical applications for DC to DC converter. So here, voltage regulation, already we have seen about the voltage regulation. What we are saying, By using DC to DC converter, we are supposed to make output voltage constant irrespective of changes in the input voltage or changes in the load or changes in the temperature. In that way, we are saying we will get different parameters in the voltage regulations. These are nothing but line regulations, load regulations, and temperature stability. So about line regulations, we are saying we are calling line regulations. It will be used to maintain constant output voltage, but if there any change in the input voltage vary at that time also, irrespective of changes in that input voltage, it will give us constant amount of voltage. So we are saying here for the line regulations, it will use to maintain constant output voltage when the input voltage varies. So we can define mathematically line regulation as it is the percentage change in output voltage for given change in input voltage, or we can say it is the ratio of output voltage, change in output voltage with change in input voltage. So we can calculate line regulations like delta V out. Delta is nothing but a change in. So we can say delta V out upon delta V in, and if you are calculating in percentage form, you can multiply that value with 100. Or we can say line regulations, it can be calculated as delta V out upon delta V in. In denominator, there will be again V out into in numerator 100%. So we can say line regulations equal to delta V out upon delta V in, V out into 100%. And about load regulation, we can see it will be used to maintain the constant output voltage when the value of load will vary. It means what? Irrespective of changes in the load value, load regulations will give the constant output voltage. So we can mathematically calculate load regulations as it will be percentage change in output voltage from no load to full load. And mathematically, you can calculate load regulation as VNL minus VFL upon VFL into 100%. If you see, we can see here, this is the Thevenin circuit. So here, if we are having the value of Thevenin voltage, we can say that will be the voltage without load, because at that time we are not considering any amount of load. So here we are saying RTH equal to R out. So here we say we will get the maximum power according to the maximum power theorem. So here, if we are calculating the V out according to the voltage divider rule, you can calculate V out equal to VTH into RL upon R out plus RL, but VTH equal to VNL. So you can write V out equal to VNL into RL upon R out plus RL. योगिता आवाज आ रही है अच्छे से? स्क्रीन दिख रहा है? Okay. So here, if you see, we are supposed to solve some numericals. These are on the voltage regulations, line and the load regulations. So if we are having the question like the input of certain regulator increases by 3.5 volt. It means what? It is the change in input voltage. So we can take delta V in equal to 3.5 volt. And as a result, the output voltage increases by 0.042 volt. So we can take that will be as delta V out. So here delta V out equal to 0.042 volt. And here they are giving us nominal output is 20 volt. So here, if we are having the value of output voltage, that is nothing but 20 volt, and it is a change in output voltage. So determine the line regulations both in percent and in percentage per volt. So percentage per volt के लिए delta V out upon delta V in, V out into 100%. So here we can calculate line regulation in percent form, like it will be the ratio of delta V out upon delta V in into 100%. Here we are having value of delta V out equal to 0.042. So we can take that value in numerator. Here in denominator we are supposed to write for delta V in. तो यहाँ पे हमें delta V in का value क्या मिल रहा है? Here we are having the value 3.5. So we can write here in the denominator. Into 100% we can take as it is. And if you solve these values, if you solve, you will get value 1.2. So here we can say line regulation percent equal to 1.2%. If you are solving line regulation in the percentage per hold, we are having the formula. Which formula? Delta V out upon delta V in into V out into 100%. So we can write these values as 0.042 upon 3.5 into 20. 20 यहाँ पे लिखा है, that will be in the denominator. So you will get 0.042 upon 20 into 3.5 whole bracket close. यहाँ पे यदि if you are writing these things in a bracket, after that you can multiply that value with 100% because we are supposed to find the line regulation in the percentage form. So you will get here value 0.06%. So here, if we are supposed to solve another example, line regulations, you can solve this question at home. I have given here answer. You can check your answer with that, with this answer. So here, if we are supposed to solve for the load regulations, we can solve third question. So here, what is the question? If a 5-volt power supply has an output resistance of 80 milliohm and specific maximum output current of 1 ampere. Calculate the load regulation in percent and the percentage per milliampere. How we can calculate? Harshita, you are supposed to join class on 8:45. Okay, please next time join on time. Okay, so here you can see here because we are solving the numericals. So you all are supposed to join the class. At that time only you will get the things how to solve. Okay, so actually in exam also there will be question on the numericals for the voltage regulation. That will be online or that will be on the load regulation. So here we can see here, see Harshada, here we are supposed to solve third question. So here, what is the question? If a 5-volt power supply, it means what? Here we are having the value of voltage that is nothing but 5 volt. So here, if 5-volt power supply has output resistance 80 milliohm, this is the output resistance and specific maximum output current. Output resistance दिया है, output current दिया है, so you can derive the value of output voltage. Because according to Ohm's law, V equal to IR. Here we are having the value of resistance. Here we are having the value of current. So we will get V equal to IR 80 into 1 milliampere. That will be 80 millivolt. So calculate the line regulation in percentage and percentage milliampere. So we are having the formula for percentage that will be VNL minus VFL upon VFL. But they have given here that voltage that will be no load because they have given here. If 5-volt power supply has a output resistance, so they have given this voltage with no load and we are supposed to find that voltage with load because they have given here when we are having the resistor. So we can calculate that will be VFL equal to 5 volt minus that resistance into current 80 milliohm into 1 ampere. You will get here 80 millivolt. So 5 volt minus 80 millivolt, you will get that value as 4.92 volt. So we are having the formula for load regulations that will be equal to VNL minus VFL upon VFL into 100%. So we are having the value, all these value, VNL, VFL. You can put, you will get the answer. हर्षदा स्क्रीन दिख रहा है, आवाज आ रही है अच्छी से? Your voice is not coming. You can put a message, okay? You can mute yourself and you can put a message. Please mute yourself. Okay. आवाज आ रही है हर्षदा?
Okay, okay,
हाँ. See here.
okay,
हाँ. So here we are supposed to solve for load regulations that will be in the form of percentage milliampere. So we are having the formula that only what we are supposed to do, we are supposed to solve that with respect to 100 milliampere. आवाज आ रही है? Okay. हाँ. So here you can see we are having the value here 1.6%. We are supposed to solve with respect to per milliampere. Milliampere means 10 raised to minus 3, or you can type 1000 milliampere. So you can take 1.6% upon 1000 milliampere. So you will get that value as 0.0016% per milliampere. Like that, you can solve fourth question at your home. You can practice and you will get the answer. You can compare your answer with this. Okay, so here. Now we are supposed to study about the linear voltage regulator. In linear voltage regulator, we are having the two types. These are nothing but series voltage regulator and shunt voltage regulator. In series voltage regulator, we are saying control element will be in series. You can see here I am taking both diagram on one page. So you will get the thing. How there is a difference in between shunt and series. So here you can see what we are saying in the series voltage regulator or DC-DC converter. Control element is in series with the load. But here if you see, this is the load and control element is in parallel with the load. So we are saying we are having series DC to DC converter in which we are taking control element that will be in series with input and the output. So here we can take output voltage sample from the sampling circuit. We can give to the control circuit by error detector, and we can compare that value with the reference voltage which we will get from the Zener diode, reverse bias Zener diode. So here we can see this is the series voltage regulator. Now what we are saying here, if you see, when we are having the control element that is in parallel with the load resistance, at that time we are giving feedback signal to the comparator circuit and it will compare that voltage with the reference voltage. Here also we are using the Zener diode for the reference circuit. So here we are saying we will require linear voltage regulator, but it is having limited efficiency and it cannot give output voltage that will be greater than input voltage. So here if you see the linear voltage regulator, this will provide the output voltage but that will be equal to or less than input voltage. So this is the disadvantage for the linear voltage regulator. It is having limited efficiency and it cannot boost voltage more than the input voltage. But if you see, it is having applications, it is having advantages, like it is having low cost, its noise is low and it is very simple to use. So here we can see, if we are having the series linear voltage regulator, at that time what we are saying here, we are saying control element. Here we are using any one type of transistor as a control element and it will be in series with input and the load resistor. But at the output we are using the voltage divider circuit which will give us feedback signal and which we can compare with the reference voltage which we will get from reverse bias Zener diode. So यहाँ पे sample circuit के लिए हम क्या use करें? We are using the voltage divider circuit. So here if you see, if we are having these values, ideally if you calculate the output voltage, we will get according to Ohm's law, according to voltage divider rule. How will you get? If we are having the total input voltage, that is nothing but here V reference into you can take, we are supposed to calculate the output voltage that will be for this R3. So you can take R3 upon R2 plus R3 into VRF. VREF. That is nothing but we are taking by using the voltage divider rule. If you simplify that, you can write that equation as V out equal to 1 upon 1 plus R2 upon R3. Same equation. क्या हो जाएगा तुम्हें equation क्या मिलेगा? If you are taking 1 plus R2 upon R3, you will get R3 plus R2 upon R3 into VREF. So here, if you solve output voltage, you will get the equations by using this two resistor voltage divider circuit. You are getting the equations like 1 plus R2 upon R3 into VREF. So here, if you are calculating the current flowing through this resistor R1, we are having the node analysis. If we are supposed to find the current flowing through this R1, you can see here, यहाँ से यहाँ का we are taking direction down. तो मुझे यहाँ पे node analysis we are supposed to use. How we can use for this? We are supposed to find the current. So जहाँ से start हो रहा है वहाँ का voltage, जहाँ पे stop हो रहा है minus वहाँ का voltage divided by this resistance. So you can take IR1 equal to V in minus VREF upon R1. So you will get that current that will be equal to Zener current, IZ, because if you see both are in series. So here we can say that current is a Zener current. So here, if we are solving value for the resistor R1 in the form of power, P is nothing but we are using for the power, and we know power is nothing but V into I. So you can write here I square R. So if you solve that equation, these equations, if you are writing here R1 equal to, what will equation become? क्या बनेगा? V in minus REF upon IR1. But if you are solving numerator and denominator both by V, तो यहाँ पे V in minus VRF है. Again you are multiplying V in minus VRF, you will get here square, and in denominator you are getting I into V in minus REF. So you can take that will be as a power. So you will get that equation for resistor. And if you are solving for IR2 and IR3, you will get according to the Ohm's law I equal to V by R. So you can take V out upon total resistance. That will be R2 plus R3. So here, if we are having one example, we can see how to solve. Here we are supposed to solve the numericals on our third unit. That is nothing but voltage regulator. We have seen previously just about how to solve the questions on line regulation, load regulation. Now we can solve the numericals on series linear regulator. So if we are having the question like this, you can see here for V in 50 volt, we can take V in value 50 volt. R2, R3, the same circuit diagram, same circuit diagram. R2, R3, 10 kilo ohm. R1, 1 kilo ohm. VZ, 5.1 volt. This is nothing but the reference voltage. Find V out, IR1, IR2, IR3, IZ. So what we are saying, IZ is nothing but the current flowing through this R1. That will be VZ का value है हमारे पास, वहाँ का resistance है. So you can calculate the value for the IZ by using the our which rule? By using the node analysis. So how we can solve here? Firstly, we will solve for the V out. We are having the equation directly for V out. So we can use that equation directly. Which equations? V out equal to 1 plus R2 upon R3 into REF. If you are solving this, you will get 1 upon, यहाँ पे R2 plus R3 चाहिए, यहाँ पे, here R2 upon R3. By mistake, here is R1 upon R2. But our equation is V out equal to 1 plus R2 upon R3. So you can take here 1 plus R2 का value क्या है? We are having R2 value as 10 kilo ohm, R3 as 10 kilo ohm. So 1 plus 1, that will be 2 into we are having the value of VREF, that will be VZ, 5.1 volt. So 2 into 5.1, so you will get 10.2 volt for the output voltage. Now we are supposed to solve for IR1. How we can solve? By using the node analysis. How we can solve? V in minus VREF. So we are having V in का value क्या दिया है उन्होंने? They are given here 15 minus VREF, that is nothing but VZ. You can take 5.1 upon that resistance R1 का value क्या दिया है? They have given R1 as a 1 kilo ohm. So 15 minus 5.1 upon 1 kilo ohm, you will get 9.9 milliampere, and this is the current flowing through R1 and this Zener diode. So you can take IR1, that will be equal to IZ. तो यहाँ पे हमें V out मिल गया, IR1 मिल गया, IZ, और IR2 का मिल गया, तो it will be equal to IR3. So here we can solve IR2 equal to IR3, that will be equal to V out upon R2 plus R3. V out का value हमें अभी मिला है, what we have get? 10.2. So you can take that value in numerator, in denominator you can take values for R2 and R3. These are nothing but 10 kilo ohm. So you will get 10.2 upon 10 kilo ohm plus 10 kilo ohm. So you will get that value as 0.51 milliampere. So that value will be for IR3 also. So here we can solve numerical on series linear voltage regulator. Now we can see another one example. If we are having the values for V in, but here we are having the value of power. So we are having these equations also. If they are not giving the value for resistance, that is in series with that Zener diode, we can calculate. How we can calculate? We are having the formula R1 equal to V in minus VREF square upon PR1. So here they have given values of input voltage, they have given value of power, that will be for Zener diode. They have given reference voltage, design a series regulator. So here we are supposed to solve and we are supposed to draw this diagram. We are supposed to write these values. So here to yield a regulated output voltage 8 volt. So here we are supposed to solve value for series voltage regulator. How we can solve? We will needed the values for R2 and R3. How will you get? If we are having these values, V in, power across Zener diode, power for Zener diode, voltage across Zener diode we are having. So we can solve. We are having the formula for output voltage, that will be equal to 1 plus R2 upon R3 into VREF. So here we can write that voltage is nothing but VZ. But here we are not having the values for R2 and R3. But we are having the value for VZ and we are having the value for VZ and we are having the values for output voltage. So we can put this value, so you will get values for R2 upon R3. If you are putting here 8 volt equal to 1 plus R2 upon R3 into VZ का value क्या दिया है? 2.4. If you are writing that equation, you will get values for R2 upon R3. So you can write R2 in the form of R3. So if we are choosing the values for R3 10 kilo ohm, you will get R2 as 23.33 kilo ohm. And if we are putting R2 equal to 10 kilo ohm, तो R3 का value हो जाएगा ये 23.33 kilo ohm. We can solve by that equation. So here now we are having the value for power, so we can calculate current. That will be current equal to P upon V. तो P कितना है यहाँ पे? They have given 500 milliwatt और उसका voltage कितना है Zener का? 2.4. So you can take IZ equal to PZ upon VZ, that will be equal to 500 milliwatt upon 2.4 volt. So here you will get value of current flowing through Zener diode, that will be equal to 208.3 milliampere. Now we are supposed to solve that value of resistance for this R1. How we can solve? We are having the formula V in minus VREF square upon PR1. If you are putting these values or instead this power, if you are solving, V in minus VREF upon IZ. Both are having the same meaning. Both are having same meaning. हम क्या कर रहे हैं यहाँ पे वोल्टेज से न्यूमरेटर और डिनोमिनेटर को मल्टीप्लाई करेंगे तो हमारा इक्वेशन ये हो जाएगा. सो हियर इफ यू आर सॉल्विंग in in the form of voltage and current, you will get equations for resistance that will be R1 equal to V in minus Vz upon Iz. So you can put the values, you will get values for R1 that will be 65 ohm. So here we are having all these values. So here we can see, we can solve efficiency. Efficiency is nothing but V out upon V in. V out का value है, we are having the value for V in. So you can say here we are getting the 50% efficiency. And if you solve V out maximum, that is nothing but VBE. That will be equal to V in minus VCE. So you will get 16 volt minus 0.2. That will be 15.8 volt. You can draw this diagram and you can write the answers. Okay, so here now we are supposed to solve numericals on the shunt voltage linear regulator. And what we are saying, if we are having the control element, you can see here we are having the control element that is in parallel with this circuit. This is nothing but the load resistance output. So here we are supposed to solve numericals for the shunt voltage regulator, and here we will get the equations for V out. That will be, here we are taking R3 plus R4 because here we are having two resistance here. R1 यहाँ पे R2 है, बट वहाँ पे क्या था, हम यहाँ पे R1 ड्रॉ कर रहे थे. We are drawing here, यहाँ पे ये ट्रांजिस्टर ड्रॉ कर रहे थे. You can see here we are drawing here the transistor. We are not taking here any resistor. So here if we are drawing transistor that is in parallel with this sample circuit, and we are taking here additional resistance. So here our equations will same, only we are having here resistance R3 and R4. So here you will get output voltage equal to 1 plus R2 upon R3 की जगह आएगा यहाँ पे R3 upon R4 into VRTF. And remaining you can solve like if you are supposed to solve IZ. How will you solve? You can solve according to any method. If you are using node analysis, you can solve here V in minus VZ or VREF upon R2 because यहाँ पे R2 है. So we can call this current as IZ or you can call IR2. You can calculate power, that will be Vz into Iz. You can rewrite that equation in the form of current. If you are solving the value for this R1, how will you solve? Because we can solve the value for current IR1. How we can solve? According to the node analysis. If you are solving, we are having directions from V in to V out. So you can take IR1 equal to V in minus V out upon R1. You can rewrite that equation in the form of R1. So here you will get these equations. If you are solving for IR3, you will get V out upon that total resistance, that is R3 plus R4. So you can say IR3 that will be equal to IR4 because we are using here voltage divider circuit. So here we can solve one numerical. You guys can see here if we are having the value for input voltage. They have given here the value for input voltage is 15 volt. The value of resistance R1 equal to 30 ohm, R2 1 kilo ohm, R3, R4 10 kilo ohm, and you are supposed to solve, find the power rating for R1. So here, how we can solve? See here, if we are having all these values, we are having here the values for power. How we are having the values of power? Because if you are multiply here numerator and denominator by IR2, you will get power. Power equal to V in minus V out square upon R1. So here if we are taking V out equal to 0 volt, because they have given here we are supposed to take values of input voltage R1, R2, R3, R4, and they are saying find the power rating for the R1. So if we are considering V out equal to 0, At that time, we can put here values of V in, values of R1, you will get PR1, that will be 7.5 watt. You will get power, that will be 7.5 watt. If we are having another example, that is like V in equal to 12 volt, PZ they have given, VZ they have given, current value for the R1, that R1 they have given. Design a parallel or shunt linear voltage regulator to yield regulated output voltage. So we are having the output voltage formula, V out equal to 1 plus R3 upon R4. R3 and R4 they are giving the same. So you will get 1 plus 1 into 2.4, because R3 or R4, what we are saying here, we are supposed to calculate the R3 and R4. They have not given the value, so we cannot take these are same, we are supposed to take that value as it is. Vz ka value they are giving here 2.4, so 1 plus R3 upon R4 into 2.4, that will be equal to V out. V out kitna hai? 3.3, so you can write that will be equal to 3.3. So you will get equations for R3 and R4. So you are having here R3 upon R4, that will be equal to 0.375. So here, if you are putting the values for R3 in the form of R1 and you are considering any one value 10 kilo ohm, you can consider any one value, you can consider. If they are not giving in series shunt, you can consider any value as a 10 kilo ohm. You can see here I am choosing here also 10 kilo ohm. You can take that value as R3 or R4. If you are considering R3 equal to 10 kilo ohm, you will get R4 1 upon R4, that will be equal to 0.37 upon 10. So 10 into 10 raised to 3, because we are taking 10 kilo. So you will get value of R4 at 3.75 kilo. So here, now we can solve for the IZ. How we can solve? We can solve in the form of power, because they have given the value for power. Power upon VZ. We are having PZ, VZ. We can put the values. You will get value for current, that will be 208.33 milliampere. I am putting the same equations you can see here. We are having here also value the same. So here, if we are solving, just wait. If you are solving for the R2, we are having the equations for R2, that is nothing but R2 equal to, you are having the equations R2 equal to V in minus Vz upon Iz. So you can take V in minus Vz upon Iz. We are having the value for V in, we are having the values for अभी आ रही है आवाज हर्षिदा? आवाज आ रही है योगिता, हर्षिदा? Okay, so you guys can see here, when we are supposed to solve for R2, we are having the formula. Okay. Okay. So you can see here. You can mute yourself. There was network. You can mute yourself. Okay, when we are solving for the R2, we are having the formula V in minus Vz upon Iz. We are having all these values, so we can put, you can solve like we are having the value for E in, they have given 12 volt. You can take 12 volt. We are having the value for Vz 2.4. So you can take 12 minus 2.4 and Iz just we have solved. So we can take upon 208.33 into 10 raised to minus 3 ampere. If you solve this, you will get R2 as a 46 ohm. Now you can solve for R1. We are having the equation like V in minus V out upon IR. If they are not giving the output voltage and we are taking the output voltage 0 volt, at that time we can, here if you see, we can solve the values for R1 like V in we are having 12. 12 minus 0 upon 50 milliampere, that will be equal to 240 ohm. And if you see here, we are having the power that will be greater than V in minus V in into V in into that current, that is nothing but 0.05. So you will get that value equal to 0.6 watt. So here we have solved the numericals on the shunt voltage regulator. Remaining syllabus we can see in the next session. Now I am taking your attendance, just wait for a minute. If anyone is facing any issue, you can ask. Okay, now I am taking your attendance. There will be unit test tomorrow. Yeah, on tomorrow. Today is Wednesday, no? Yes. Okay. Okay. You guys can leave now. Thank you.